All right, 8th graders, lesson 70, direct variation. And recall proportions, we talked about that last lesson. And here we have some different ratios that we can make. And if you remember, the second number always goes on the top. So 15 over 1, 30 over 2, 45 over 3, and 60 over 4. If we were to reduce those or divide each of them, we would realize that the constant would be 15. So 1 CD is 15, 2 is 30, 3 is 45, and so forth. So that if they asked us, well, how much is 6 CDs, you could say, well, I'm going to multiply that by my constant, 15. And 6 times 15 would be $90. $90. You could say 6 CDs equals $90. So when you know that two quantities are directly related, the number of CDs that you want and the price, it allows us to solve for the other. So if this is a y equals mx type of problem, or a k, if we put that in there for the constant, then we can say graph pairs and put in y equals, in this case it would be 15 times x. So whatever we put in for x, if we put in the number 1 like we did up here, we get a 15 out. If we put in a 2, we get a 30. So we could graph this if we needed to. All right, here in example 1, the amount Ellen charges for banquet food varies directly as the number of people that attend. So by saying directly there, it's showing us that it's going to be a constant. If Ellen charges $780 for 60 people, then how much does she charge for 100 people? And we can solve that because we know that if we take this problem up here, we can say 60 times the constant k will equal 780. Now to solve this type of problem, we would do the opposite of multiplication, which is division. So we can go ahead and make a division problem over here. 780 divided by 60 will go in there one time. Left with 18, bring down the 0. 60 will go into 183. So her price is $13 a person. So now I can go down here and say 60. Actually, I could say 100 because I'm taking this number up over here. 100 times the constant 13 will be 1,300. So the price for 100 people will be 1,300. So her constant is $13 per person. Okay. And we can now make a formula with that so that I could graph all kinds of numbers. I could say y is going to equal 13 times x. That will be my formula. In example 2 here, driving at a constant speed, so it's staying the same, the distance Margie travels varies directly with the amount of time she drives. So the more time she drives, the farther she goes. That's what that varies means there. If Maggie drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? So again, first we have to find out her k, her constant. She travels 1.5 hours, and that equaled 75 miles. So we want to know how long will it take her to drive 100 miles. Well, again, we can take the constant 1.5 times the constant k equals 75 miles. This is supposed to be hours here. So now I divide 75 divided by 1.5. Gonna move that one place, move the decimal one place over here. So 15 into 75, that will equal 5. It'll be 0, bring down the 0, so that'll be 0. So she's traveling at 50 miles per hour. So the k, the constant, is 50 miles per hour. So y equals 50 times x, whatever number you want to put in there. Now in this case, we have y is the answer So 100 equals 50 times x. Again, we would divide both sides by 100 and 100 or by 50. 100 divided by 50 would be 2 hours. So it's going to take her 2 hours to go 100 miles. All right, let's take a look at example 3. There are 23 people in line in front of Delia waiting to be helped. 3 minutes later, there were 18 people in front of Delia. Predict how much longer Delia will wait to be helped. Now, if you're waiting in line, you know that some people take longer and some take shorter, but they're assuming, okay, by using a prediction, they're allowing us to round or estimate or assume that there's a constant here. So we're going to say we started out with 23 people, and now there's only 18. So that means 5 people were served. In 3 minutes. So there's 18 people left. How long will it take to get rid of those 18 people until it's Delia's turn? Okay. So again, to figure out the constant, I say 5 people actually here, we better erase that a second. 5 people, and they're each being served with a certain amount of time equals 3 minutes. So how much time is each person getting attention? Well, we can divide that. 3 divided by 5. That'll be 0, that'll be 0.6. So 0.6 minutes a person. So our constant is y equals 0.6 minutes times x. So now we know there are, go back over here. We know there are 18 people. So we're going to do 0.6 minutes. Each person gets that amount of time times 18 people. And that will equal 0.6, 6 times 8, that's 40, that's 48. 6 times 1 is 6, plus 4 more will be 10, put 1 decimal, so y will equal 10.8 minutes, and because it was rounded, I'm going to say, so it's approximately in 11 minutes Delia will be served. That would be our answer, in approximately 11 minutes. So we can take our beginning information, transform it by putting the constant where it should go. Then we can do the math to figure out what the constant should be, put that into a formula, and then we can start putting in our numbers. That's it for today. You can get started on your lesson practice here.